reality may not be made of matter at all. It may be made of numbers. Welcome to Information World. Imagine that everything you see, touch, and experience, space, time, stars, your body, even your thoughts, is not fundamentally physical. Instead, imagine that the universe is a vast mathematical structure, where every object, law, and event exists because it satisfies a set of mathematical relationships. In this view, the universe does not merely follow mathematics. It is mathematics. This idea sounds abstract at first, almost philosophical, but it has deep roots in modern physics, cosmology, and the foundations of reality itself. For centuries, humans have noticed something strange and unsettling: mathematics does not just describe the universe well, it describes it perfectly. Equations written by humans on paper predict the behavior of galaxies, black holes, atoms, and even particles that had never been observed before they were mathematically discovered. This raises a profound question. Why does mathematics work so well? Why does reality obey abstract symbols invented by the human mind? And more unsettling still, what if mathematics was not invented by us at all, but discovered? What if the universe exists because it is a mathematical structure? To understand this idea, we need to step back and ask a deeper question: what do we mean by existence? In everyday life, we think something exists if it is physical, if it has mass, takes up space, or can be measured. But physics has slowly dismantled this intuition. At the deepest levels of reality, particles are not solid objects. They are excitations of fields. Fields themselves are described entirely by equations. Space and time bend according to mathematical tensors. Even causality emerges from mathematical rules. The physical world, when stripped of its sensory appearance, becomes a web of relationships. And relationships are mathematical. One of the strongest advocates of this idea is the mathematical universe hypothesis. This hypothesis suggests that the universe is not described by mathematics, it is a mathematical object. Just as a triangle exists because of the relationships between its angles and sides, the universe exists because of the relationships between its fundamental components. In this view, there is no deeper stuff underneath reality. No hidden substance behind the equations. The equations themselves are the substance. Think about a simple example: a video game. Inside a game, characters experience space, motion, time, and interaction. But from the outside, the game world is nothing more than code, mathematical instructions running on hardware. The characters inside the game never see the code, but the code completely defines their reality. Now imagine that our universe is similar, except there is no external computer. The mathematical structure exists on its own. It does not need to be implemented in anything else. It simply exists because mathematical structures do not require physical instantiation to be real. This leads to a shocking implication: physical existence and mathematical existence may be the same thing. If that is true, then every consistent mathematical structure exists somewhere. Our universe is just one of them, one that happens to be complex enough to produce self-aware observers like us. This idea also offers a possible explanation for one of the biggest mysteries in science: why the laws of physics are so finely tuned. The constants of nature, like the strength of gravity, the charge of the electron, or the speed of light, seem to be set to extremely precise values. If they were slightly different, stars would not form, chemistry would collapse, and life would be impossible. Instead of asking why the universe was designed this way, the mathematical perspective asks a different question. Out of all possible mathematical structures, only some allow for observers. We exist in one of those structures because only such structures can be observed. In other words, we do not live in a life-friendly universe by coincidence. We live in a life-friendly universe because only such universes can contain beings who ask questions about existence. This shifts the idea of why into something deeper. The universe does not need purpose or intention to exist. It exists because it is mathematically consistent. And we exist because we are part of that consistency. Now let's go even deeper. If the universe is a mathematical structure, then space and time may not be fundamental. They may be emergent properties, like temperature emerging from the motion of atoms. At the deepest level, reality could be timeless, static, and purely relational. From this perspective, the universe does not evolve in time. Instead, the entire history of the universe exists as a single mathematical object. Past, present, and future are all equally real. What we experience as the flow of time is simply our conscious movement along a path inside this structure. This idea aligns surprisingly well with modern physics. In relativity, time is not absolute. Different observers experience time differently. In quantum mechanics, particles do not have definite properties until measured. In cosmology, the universe can be described by equations that do not require time to flow at all. Time, like color or sound, may be a feature of perception rather than a fundamental ingredient of reality. If that is true, then every moment of your life already exists mathematically. Every choice you make is a location within the structure. Free will, in this view, is not about changing the structure, but about experiencing different parts of it. This brings us to consciousness. How does awareness fit into a mathematical universe? If everything is mathematics, then consciousness must also be a pattern, a particular kind of information processing that occurs within certain mathematical arrangements. Your brain, made of neurons and electrical signals, follows physical laws. Those laws are mathematical. The activity of your mind is therefore a mathematical process unfolding within a larger structure. This does not make consciousness meaningless. In fact, it makes it extraordinary. Consciousness becomes the universe observing itself from the inside. You are not separate from reality. You are a localized expression of its structure, capable of reflecting on its own existence. Now consider this question: if the universe is a mathematical structure, could there be other universes? The answer, disturbingly, is yes. Infinitely many. Every mathematically consistent structure exists. Some are simple. Some are chaotic. Some contain no complexity at all. Others contain stars, galaxies, life, and intelligence. Our universe is not special because it exists, but because it is complex. This idea challenges the traditional notion of reality. Instead of asking which universe is real, we ask which structures allow observers. Reality becomes observer-relative, not in a subjective sense, but in a structural one. We are not at the center of existence. We are at a point where mathematics becomes self-aware. This perspective also reshapes how we think about meaning. If the universe has no external purpose, does life lose its meaning? Not at all. Meaning does not need to be imposed from outside. It can emerge from within. In a mathematical universe, meaning arises from relationships, experiences, values, and conscious interpretation. Purpose becomes something created, not assigned. You matter not because the universe was designed for you, but because you are part of the structure that gives rise to meaning itself. Even suffering, uncertainty, and chaos take on a different role. They are not mistakes in a flawed design, but features of complex mathematical systems. Without instability, there is no evolution. Without uncertainty, there is no choice. Without contrast, there is no experience. Now let's address a common objection. If the universe is just mathematics, why does it feel real? The answer may be that feeling real is exactly what certain mathematical structures do. Just as a sufficiently complex simulation can produce immersive experiences, a sufficiently rich structure can produce subjective reality. Reality feels real because it is internally consistent. You cannot step outside the universe to compare it to something else. From within the structure is all there is. And this leads to the final, most unsettling idea. If we are living inside a mathematical structure, then the distinction between physical reality, simulation, and abstraction begins to dissolve. A simulated universe, a computed universe, and a mathematical universe become different descriptions of the same thing. What matters is not how the structure is implemented, but what relationships it contains. This means the deepest truth of existence may not be particles, forces, or even energy, but structure itself. Patterns, relations, numbers. And somehow, against all odds, those patterns learned how to ask questions. They learned how to wonder. They learned how to say I am. And that may be the most astonishing equation of all. If this kind of deep thinking fascinates you, don't forget to like the video and subscribe to Information World for more explorations into reality, consciousness, and the hidden structure of the universe.